Hey guys, welcome back. Let's do the next part of the study guide. So we ended with this one, negative 8.22. We're trying to turn that into a fraction. Whenever we turn a decimal into a fraction, first thing we look at is to see what place value the number ends in. This number ends in the hundredths place. So if it ends in the hundredths place, that's going to be my denominator. Then whatever is after the decimal, I go and put in the numerator. We got 22 after the decimal. I'm going to put that into the numerator right here. And then look at this before the decimal. I have this negative 8. If it's before the decimal, that means it's like a whole number. So I have negative 8 before the decimal. I'm going to put it right here. Negative 8, and then this 22 over 100. Notice how I put the negative with the 8. I don't put it up here with the 22. It stays with the whole number. Now, this 22 over 100, I could simplify that. We never simplify with the whole number. It stays how it is. But the fraction, we can simplify. So 22 over 100, I know they're both even numbers. I could simplify them both because they have a GCF of 2. They both have a factor of 2. This will work out to be 11 over 50. 22 divided by 2 is 11. 100 divided by 2 is 50. So this would work out to be negative 8 and 11 over 50. That's the simplified fraction of this decimal right here. Let's look at the next one. What is the difference between a repeating decimal and a terminating decimal? A repeating decimal, I'm going to abbreviate a little bit just for space, okay? Repeating decimals repeat, of course, a number or pattern of numbers forever. They never stop. Some examples might include, let's see, 0.2. And look how I signify a repeating decimal. I put a line underneath the part that is repeating. 0.2 repeating, 1.793 repeating. Notice if the line is over the 3, that is the part of the decimal that's repeating, okay? The 7.9 won't come up again. The 3, however, will keep going forever and ever and ever, all right? Or negative 4.25. Maybe the 2.5 is repeating, so this would be 2.5, 2.5, 2.5, 2.5, forever and ever. Whatever is repeating, the number or series of numbers, that's what I put a line over, okay? Let's look at the next one. Convert the following fractions into decimals. I'm actually going to start with this one right here. Whenever we're converting fractions into decimals, we look at the denominator. Now, sometimes we get lucky, and the denominator is exactly what we want it to be to make this kind of easy. So, whenever we have a decimal, like 5.387, the first number behind the decimal is in the tenths place. The next number is in the hundredths place. The next number is in the thousandths, and then so on and so on and so on. All right? Whenever we have something like this, the denominator, if it's already a place value, meaning this is already tenths, I can just go ahead, start my decimal, and I know that my decimal has to end in the tenths place. Here's 0 point, and then my decimal has to end in the tenths place. What number is going to go right there? This one right here, the numerator, 0.3. Let's look at the next one. Let me give this bit an erase above it just so I have plenty of room to write. There we go. Oh, you know what? I didn't put the next piece. This says repeating and terminating. A terminating decimal, let me come back to this so I don't forget. A terminating decimal has an endpoint. So it's the opposite. It ends. Things like negative 4.2 or 12.95 or 3.8924, and that's it. As long as it ends, it's a terminating decimal. Sorry about that. Let's get back over here. We had negative 27 out of 100. So this 100 in the denominator, luckily, that's a place value. This is the hundredths place. So I know when I write my decimal, I have to go all the way out to the hundredths place. What's going to go in those blanks? The numerator goes in those blanks, 27. I keep the negative, not with the fraction part because we don't see decimals written like that. We keep the negative out here with the whole number. Negative 0.27. Or 0 is not a whole number, it's like an integer. but I keep the negative out there with it, okay? What if this said negative 27 over 1,000? If that had been the case, I would have to go to the thousandths place. So I'd have 0.1, 2, 3. I'd have 3 spaces because that's the thousandths place way over here. And I would make sure the 27 extends all the way to the thousandths place. So I have that 0, so I can make sure that 27 goes all the way to the thousandths place, okay? And then, of course, I'd have my negative out here in front of the 0. And give that an erase. So let's get back up here. Now, this one over here, negative 2/5. There is no such thing as a fifths place. We have tenths, 100ths, 1,000ths, 10,000ths, 100,000ths, but we don't have a fifths place. But sometimes we get lucky and we have a denominator that we could turn into a place value that we know. Can I turn a 5 into a 10 or a 100 or 1,000? Yeah, we could. We want to go to the closest number to make the least amount of work for us. The closest number to that 5 would be this 10 right here. So if I wanted to turn a 5 into a 10, this is kind of like doing common denominators, right? That 5 into the 10, I would multiply by 2. I would do the same thing to the top. Negative 2 divided by 2 is negative 4. And now look, this is my new fraction. It has a denominator of 10, which I actually already know is a place value. So here's my decimal. I know if it's in the tenths place, I'm looking to have the decimal extend this far. I put my new numerator of 4 right there. And then the negative is out front. So now I have negative 0.4. Let's look at the next one. 3/4. I'm always going to look and see first if I can turn the denominator into one of the place values that I know. I know I can turn this 4 not into a 10, but I could turn it into 100. So I could turn 4 into 100 by multiplying by 25. If I do it on the bottom, I have to do it on the top too. 4 times 25 is 100. 3 times 25 is 75. So now this is my new fraction. It's in the hundredths place. That's how many, it's my denominator, so I know my fraction, or my decimal has to extend out to the hundredths place. And what goes in the blanks? The numerator, 75. 0.75 is what we're talking about right there. Let's look at the next one. Can a fraction have a denominator of 0, such as negative 8 over 0? Hint, it cannot. But why? The reason is because negative 8 over 0, every single fraction is really a division problem, meaning this is be like negative 8 divided by 0. If I was going to set that up, I'd have my box with the negative 8 in it, 0 on the outside. 0 can never break up any number. It doesn't have the capability. It's impossible. It can't break up any number, so it can never be used as a divisor. It can't ever be used as a divisor. It cannot be on the outside of the box. If this is the case, because your 0 is the denominator, this is, pay attention to this word right here. This would just be undefined. That's the fancy math word for this. If 0 is in the denominator, this is undefined because that 0, it can never break up any number, ever. All right? It's undefined. Notice how I'm saying it a lot. Maybe that means it's important. Undefined. Let me get my phone calculator out. Whenever you guys even try to do this on your calculator, let me try an angle so you can see the calculator. There we go. Can we see it? Perfect. Let's see. Now, if I try to do 8 divided by 0, where is it? 8 divided by 0. Watch what happens. It literally says error on it. On any calculator, you can't do it. However, if I try to do it the other way, 0 divided by 8, it gives me 0. So if the 0 is in the numerator, meaning if it was 0 divided by negative 8, that would just give me 0, and we can do that. However, if 0 is in the denominator like this, we can't do it because that would mean the 0 is the divisor on the outside of the box, and it can never split up any number. So this doesn't work. 0 like this in the denominator means it's undefined. 0 in the denominator is undefined. Let's look at the next one. Scroll down just a little bit so we have plenty of room. Give that an erase. There we go. Let's see. Back to the pen. There we go. Let's look at this. Mr. Gann and 4 of his friends went to Chili's for dinner because Chili's is incredible. That is a true story. Chili's is unbelievable. It's one of my favorites. I love it. Mr. Gann definitely got the honey chipotle chicken crispers. Absolutely he did, with extra ranch. They have the best ranch at Chili's. They spent $31.81 on appetizers, $72.94 on entrees, and $21.20 on desserts. They decided to split the total bill equally. How much would each person pay? 5 people total. So looking at this, this is their cost on appetizers, on entrees, and then on desserts. I have to first add all the food cost up to figure out how much the total bill was. $31.81 plus $72.94 plus $21.20. Let me go and add all this up. 1 plus 4, 5. 8 plus 9 is 17. Plus 2 is 19. Carry the 1. 1, 2, 3, 4, 5. 3 plus 7 is 10. Plus 2 is 12. And then I'll bring down the decimal because the decimal is always lined up whenever we add or subtract decimals. This is the total cost of the meal, $125.95. 5 people went, so they want to split that total among each of them. So they're all going to pay a little bit. So whenever we're trying to split this total up, we're talking about division. I'm trying to split the $125.95 up into 5 equal pieces. So $125.95 goes in the box. I'm going to split it up using this number 5. 5 goes into 1, 0. 5 goes into 12 twice. 5 times 2 is 10. Subtract, I get 2. Bring down the 5. 5 into 25 is 5. 5 times 5 is 25. Great. Love this. It's going well. Bring down the 9. 5 into 9 goes once. 5 times 1 is 5. Subtract, I get, oh, not 0. What? Subtract, I get 4. And then I bring down the last 5 right here. 5 into 45, that goes 9 times. 5 times 9 is 45. Hey, and I end up with a 0. That's excellent. Perfect. So this is a terminating decimal. And look, I bring the decimal straight up. So now every person is going to pay $25.19. This is one of those problems where it's really important to think, does my answer make sense? Maybe if this was your number and you were like, I don't know what to do, maybe I'll try and subtract 5 and get some kind of answer. Or maybe I'll try and multiply by 5 and get some answer. Hopefully you can see if your answer makes sense. And if it doesn't, maybe you made a mistake or maybe you chose the wrong operation. How much would each person pay? Yeah, about $25 for each person. That sounds about right. The total bill was about $125, so that sounds about right. That's what they would pay for each person. Let's look down the next one. So, oops, let me give some of this an erase so I have room to write. You know what? I'm actually going to come up on the 15-minute time limit. I'm going to call that for that part. I'm going to stop the video and I will finish the study guide with one more